Sean, I know you guys are working with NVIDIA and Roda and Schwartz. What is this partnership all about, and what specific challenges in 6G research are you guys trying to solve?
Well, specifically in 6G research, there's great challenges in these new native AI radio access network systems. Native AI means that we're going to have adaptive control on the radio. So the radio and the antenna systems will adaptively adjust to the environments in which they operate. Now that implies a real problem in training and developing the technology that's going to do this in an automated fashion. We need to know that when we put it in that environment, it's going to work exactly as designed. So NVIDIA and Synopsys and Roda and Schwartz have come together to develop a lifecycle digital twin model for radio access networks that can be evaluated and validated entirely in the laboratory before you go to installation.
That's interesting. We've been hearing quite a bit about digital twins, but why is having a digital twin important when it comes to 6G test environments?
Well, you need a digital twin to do the training. We're looking at an environment where we want these radios to be set up and to operate. We want to be able to set up adaptive control for antenna systems and for the radio. So we have to be able to streamline that for the targeted location. Now you can either do that by first building the radio, putting it on site and relying on a lot of test and measurement activity, or you can construct a digital twin model, a physics accurate model for that entire radio access network and simulate that, and then take those results and put them between the radios. So in the example you see behind me, I have a digital twin of a large warehouse environment in which some subscribers are moving around through, and we're capturing all of those signal models and then putting them into the test and measurement equipment from Roda and Schwartz, as you see below.
So why would you want to use a digital twin or digital twin testing rather than just pulling directly from the network data?
What operators want to do is to validate a system. They want to validate the programming. They want to test the programming. And sometimes they may want to use the simulation of the digital twin to reverse engineer something that went wrong in the true operational system. So having this work stream built and the ability to simulate this end-to-end will be really important to both the designers and also to the operators downstream.
I know that the demo that you're running includes an integrated workflow, so talk to me about why this end-to-end environment is important for telecom researchers and important to the future of 6G.
Well, it's going to give you a really tight loop for being able to develop and then deploy some of these algorithms. It will give you insight into the kind of radio you may want to develop or enhancements you want to build. And further, we're opening up new spectrum to address bands that haven't even really been measured that much yet. So you're going to have to rely on modeling and simulation to get that system operational as quickly as possible. Otherwise, these systems are too complex to design using the methods, the siloed methods we've been using today.